Hi there and happy Friday. So Wednesday you looked at combining like terms and adding and subtracting polynomials. Yesterday you used area models to talk about equivalent expressions. And today we're going to build off of that using the area models to multiply polynomials together. So before we do that, there's a couple vocabulary words to keep in mind, just things to look for. So a monomial. A monomial is a polynomial with one single term there. The word mono, single, one term. So some examples might be 3x, or 9x squared, or -4, 2x to the ninth. Those are all monomials. They're one term involving a coefficient and variable. A binomial, just like a bicycle has two wheels, a binomial has two terms. So something like 2x plus 1, or 6x squared minus 2, or 3x cubed plus x. Anything with two variable coefficient pieces combined with addition or subtraction. And finally, a trinomial, so mono, bi, and trinomial will have three terms. So an example might be something like x squared plus 9x plus 2, just as an example. So moving forward, when we talk about monomial or binomial or trinomial, this is what we're talking about. So to get started, we're going to practice multiplying any polynomial by a monomial, so a single term polynomial. And so this might look like something you predicted here. We're going to start by distribute the outside term. So we're going to do x times 2x squared. We're going to do x times 3x, and then we're going to add x times -5. Just like when I was combining like terms, I'm going to keep that sign in front of the value. Step 2, I'm going to simplify from there. So that means, thinking about, well, what is x times 2x squared? Well, if I think about what x times x squared is x times x. So this is x times x times x. So we'll actually get 2x to the power of 3. X times 3x would make 3x squared. And finally, x times -5 would be -5x. So we simplify there. Our third step is we combine any like terms, just like with our adding and subtracting, any like terms. So we actually don't have any like terms here. Remember, those variables have to have the same exponents. Just because we have x's doesn't make them like terms. And then finally, we're going to rewrite in standard form. And so that is the largest exponent to the smallest. So as it turns out, we actually already did that in this example. As we did it, we ended up having the largest exponent 3 in the very front, and then smallest. So 2x to the power of 3 plus 3x squared minus 5x is our product. So I'd like you to take a couple minutes here to try the next two examples on your own. I would pause the video and maybe check my work with a neighbor and then come back and double check with me. Welcome back. So when I distribute 3x to -4x plus 15 minus 2x squared, hopefully, whether you write out the full multiplication step or you do this in your head, you're going to end up with -12x squared plus 45x minus 6x cubed. So again, there are no like terms to combine here, but if you rewrite it in standard form, that cube, that -6x to the power of 3, should go first, followed by -12x squared, and then that 45x at the very end. The second example might have been a little bit more difficult because of that square, so let's double check your work here. So that's negative 2x squared times 6x plus negative 2x squared times negative 7x squared and negative 2x squared times 14. Whoops, there should be a plus in the middle here. So negative 2 and 6, that gives us negative 12, x squared, and x gives us x to the power of 3. In the next term, we've got negative 2 times negative 7. That gives us a positive 14. And then x squared and x squared. So x squared times x squared is really x times x times x times x, which is x to the power of 4. And then in our last term, negative 2 times 14, that would be negative 28. And then x squared is just x squared there. So we rewrite that. Again, there's no like terms to combine, so we don't have to worry about that. And we just rewrite it, starting with that x to the power of 4. So 14x to the power of 4 minus 12x to the power of 3 minus 28x squared. So when we multiply by a monomial, really we're just using the distributive property. And the only extra thing to think about are those variables and their exponents. So if it helps you to expand like I did over here, that's definitely a great strategy. So next we're going to multiply two binomials together. So that's two-term polynomials together. We've got two strategies here. The first one is called the box method. And the box method should look very similar to what we did yesterday with our area model. So I've got my two binomials. I've got 2x plus 9 and x minus 4. And so I'm going to build a box that has side lengths of 2x plus 9 and x minus 4. Now, I know that it seems a little bit strange to think of an area as having, or a side as having a negative length, but if we just treat it as an area being the side lengths multiplied, this will still work for us. So multiplying 2x and x gives us 2x squared. X times 9 gives us 9x for that area. 2x times negative 4 gives us negative 8x. And finally, negative 4 times 9 gives us negative 36. So just like yesterday, we're multiplying side lengths together to find areas. And then at the very end, we actually add all those pieces together. So our area is 2x squared plus 9x minus 8x minus 36. We have a couple of like terms to combine there. So we're going to get 2x squared plus 1x minus, 36, not 3x, 36. You could actually even simplify it further and make that 1 a ninja 1, so 2x squared plus x minus 36 would be the really neat and tidy version there. So for many of you, your success yesterday with the area model, the box method is just going to be a really great extension there. It's the same idea. You're multiplying one side length by the other. However, you may have noticed yesterday in your work that there was a way to do this without an area model. That was one of the last questions, was to challenge yourself to do this without an area model. And for that, we have double distribution. So if we think of this next binomial, this is 3x minus 2 times 2x plus 7. And we can think about distributing twice. So first I'm going to distribute 3x to 2x and to 7. So this will look like 3x times 2x and 3x times 7. So I distributed the 3x. But then I'm going to distribute, maybe I'll use blue here. I'm going to distribute the negative 2 to both of those pieces as well. So I'm distributing two things instead of one, like we did with the monomials. So this will be plus -2 times 2x and plus -2 times 7. So just like before, we've distributed. Now we need to simplify a little bit. So 3x times 2x makes 6x squared. 3x times 7 makes 21x. -2 times 2x makes -4x. And last but not least, -2 times 7 makes that -14. And then we end up with some like terms here. Again, the 21x and the -4x. So we'll end up with 6x squared plus 17x. 21 minus 4, I believe, is 17. So 17x minus 14. So double distribution may be a method for you. It's not any better than the box method. It's not any worse than the box method. It's applying an earlier skill that you have and using it in a new situation. So for the next two examples, I would like you to try these on your own, and you can choose either method. You might try one with the box method, one with double distribution. It does not matter. You can choose either method for these. And I encourage you, just like always, to pause here and come back and we'll check together. All right, welcome back. So we're going to check our work here. So first thing I'm going to do, this is 3x minus 2 times 2x plus 9. And I just want to give you the equivalent expression here. Hopefully you got 6x squared plus 23x minus 18. So I'm going to do this one two different ways here. I'm going to show using both methods. So if I use the box method, maybe make my box just a little bit bigger there. The box method, I have 3x minus 2 and 2x plus 9. And again, I'm just multiplying the outside, so 6x squared minus 4x plus, or plus 27x, that's fine. And then minus 18. So 6x squared minus 4x plus 27x minus 18. And then those two middle pieces will make that 23x that I got in my answer. If I were to double distribute here, first I would get 3x times 2x and 3x times 9. And then I would get -2 times 2x and -2 times 9. And so that would give me 6x squared plus 27x minus 4x minus 18. And so again, then we get those combination of like terms to make the positive 23x. So either method gets us the same exact answer. For the second example, maybe make a little space there. For the second example, x minus 6 squared, remember that this square means we're doing x minus 6 times itself. So x minus 6 times x minus 6. So depending on the strategy that you used, you should have gotten x squared minus 12x plus 36. If you didn't quite get that, first check, did you square correctly? And then maybe check your work with a neighbor or try it using a second method and verify if you can get it using a second method. The last thing we're going to do is we're going to practice multiplying a binomial and a trinomial. And so what this means is we can actually we can use our double distribution or our box method, same as we did before. So our first example, 3x plus 2 and x squared minus 4x plus 5. I'm going to do this one using the box method just to show you how that works. So since we've got a binomial, that's two terms, 3x and 2, that's fine. But my trinomial, I'm going to need to extend my box, right? So now my box is going to have room for 3 spaces, x squared minus 4x plus 5. So just like always, I'm going to multiply those pieces together. So 3x and x squared makes 3x to the power of 3. 3x and negative 4x makes negative 12x squared. 3x and 5 make 15x. 2 times x squared makes 2x squared. 2 times negative 4x, make negative 8x. And finally, 2 times 5 make 10. So when I write this out and all of my pieces, 3x squared, you might be noticing that you've got like terms kind of already, right? They're kind of standing out there, the x squared and the x, whereas the x cubed and the 10 are just kind of doing their own thing. So you could potentially combine those automatically, right? 2x squared and negative 10x squared make negative 10x squared. 2 minus 12 makes negative 10. Negative 8x and 15x make a positive 7x, and then plus 10 at the very end. So I encourage you to check mine, perhaps using double distribution. But the box method lets us have a nice visual, not just for the multiplication, but also for combining the like terms. However, double distribution still does work. Oops, 2. So in this case, instead of maybe double distribution, I'm going to think of it as triple distribution. I'm distributing 2x squared, and then I'm going to distribute negative 3x, and then I'm going to distribute a positive 6. You could also rewrite it so that the 2x minus 1 is the polynomial in front. Multiplication, you can rewrite it in any order. So I'm just going to go through that multiplication really quickly here, and then we'll be ready to get you started on your practice. So 2x squared times 2x plus 2x squared times negative 1. And then I'm going to have negative 3x times 2x and negative 3x times negative 1. And then last but not least, I will have 6 times 2x and 6 times negative 1. And so all those little pieces there, I'm going to have to do this really carefully. This will be 4x to the power of 3 minus 2x squared, 2 times negative 1 there. Negative 3 and 2 make this negative 6x squared. Negative 3 and negative 1 make that positive 3x. 6 times 2x is 12x. And then finally, 6 times negative 1 will be minus 6 at the end. And then last little bit here, we've just got some like terms to combine. So negative 2x squared and negative 6x squared. We're going to start with 4x cubed minus 8x squared. And then a couple more like terms, 3x and 12 get us to a positive 15x minus 6 at the very end. So obviously, the more terms you add, the more work you make for yourself. But either method, double distribution or the box method, turn this process into smaller bite-sized pieces that are really easy to manage. So thank you for your hard work today and all week. Please take a look at that practice assignment. Use your neighbors as amazing resources. Check out your key on Canvas and email me if you have any questions. Have a wonderful weekend.